Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro, and today's episode, I invite my friend Dan, a PhD candidate from the University of Illinois, Urbana-Champaign, to talk about our research. However, he ends up tricking me in talking about my burnout and my experience taking a sabbatical year in Brazil. In any case, in this episode, we talk about his research in the field of parallelism, more specifically garbage collection in the presence of actors. And towards the end of the episode, we talk about my research on translating GADTs from OCaml to OCaml. Let's get into it! I'm really excited for today's episode because actually a friend of mine is here with me and we're going to have an amazing conversation. This is going to be a little bit different. Usually I interview someone with, like that is a professor or something like that. But this time I'm interviewing a friend of mine that is also a PhD student and we're going to be talking about our research. So welcome to the show, Dan Plyukhin.
Hi, I'm happy to be here. And you gave the game away because I was going to introduce myself as a community radio host for East Central Illinois, 90.1 FM, playing Celtic music and jazz music once a month. And incidentally, also PhD candidate in computer science.
But you have to do those sexy host voices, like that they're really smooth, they talk like that, and the end of the night or something.
They'd never told me not to do it. But I try not to. I try to just talk normally. But yeah, thanks for having me. I'm really glad to be on.
Yeah, thanks for being here, dude. Actually, that's a really good thing that you mentioned because something that I've been thinking a lot is that often when we're doing a PhD, we are so hyper focused on being productive and feeling bad about not working on our stuff, and we forget that we should have lives, right? We should have hobbies. So it's really cool that you do some things on radio. Can you talk a little more about that? What do we actually do there?
Yeah, I mean, I finally found a hobby after 6 years. I really recommend it. And in fact, when I was starting my PhD and I was starting to feel a little bit stressed, my mom, who also has a PhD, well, she has a PhD. I don't have one yet. She said, one of the best things that you could do is have a kid right now. Because, she was doing her PhD and she had me while she was doing it. And she said, all my other classmates, they were just staying in the lab 24/7. They were getting burned out. And what I could do is I could go home. I could feed some little monkey at home, and I could feel better in the morning and recharge. And so, yeah, I just happened to find out that our local community radio station, WEFT Champaign 90.1 FM, community radio for East Central Illinois, they're always looking for new people. I bet any listeners, if you have community radio in your city, you probably do. They're looking for people to join, and so I sent an email, and a few months later I was doing a Zoom call, and then a few months later I was in front of a microphone and I was DJing some jazz, and it, there's something really magical about the radio experience, but it's also it's not very stressful. It's just you can kind of sit in a booth and do something, but it takes your complete undivided attention, so it's a real nice way to tune out from research for a while.
Not only
that's why you're doing this podcast, I guess. Is it? No, probably not, right? It's not very relaxing.
There are a few reasons why I'm doing the podcast. There is the reason that I really wanted a type theory podcast that, well, we had one before, but it was that kind of, and it's really good for my career, I think. And I'm learning things, and I usually come here and talk to another person that is extremely smart about something that I'm also excited about, and I have his undivided attention for 1, 2, maybe even 3 hours, and that's just magical. It's like he's talking directly to me, and all I do is I broadcast this to the rest of the world, which is pretty cool in my opinion. But
Yeah, there's a funny thing.
Yeah.
Like, you can't normally you walk up to some, outstanding intellectual in their field, and you're like, "Can I talk to you for 2 hours?" And like, "No, obviously not." And they're like, "What if I'm on a
Right?
podcast? What if I have a podcast?" And they're like, "Yes, sign me up." That's pretty cool.
Exactly. It's a pretty cool hack, and don't tell anyone. Actually,
Are,
honestly, I think we should have more podcasts like this. Like
uh,
Cody Rube started a podcast. It's called The Church of Lambda, which is a pretty cool name if you ask me.
uh,
And I think like I don't see that as a competition at all. I think like we all gain if we do more and we bring more people in this kind of interest. Because that's something that I see too. Because it's like type theory and this stuff that we do here, programming languages, it's pretty niche. It's small,
mhm.
especially compared, like with machine learning, with AI. That is, it's like everyone want to do that right now. PL is very very small, and we don't have like when I was here in Brazil, I felt so isolated. Like I didn't have anyone to talk about these things. I actually went to the US because there isn't that many Brazilian professors doing research, even outside of my university. So producing content in these areas, I think it's very good. It's very good for everyone. Everyone gains, right? So yeah.
Yeah. Is that like the will this be in the podcast? And it's like the type theory for all origin story. I don't know if that's been broadcast yet on your
I don't know. I think
podcast.
I think I bring this up every now and then, and I bring
Uh-huh.
pieces of this sort of stuff. But yeah, we can we can leave this
Right
in.
on.
No problem. But let's talk a little bit about your research. You said that you've been in your PhD for 6 years now.
Yeah, yeah.
Who's your advisor and what do you do?
So my advisor's Gul Aga. He's one of the founding fathers of this thing called the actor model, which I think it's kind of like lambda calculus, where like a few people have heard of it and they really really like it, and everybody else is like they've kind
Eh,
of know some words, and they're like, "Oh yeah, actor model." It's one of those things that that shows up on Hacker News all the time. It's like, "Oh, I should get around to learning about the actor model." But yeah, all of my research revolves one way or another around actors, and so it's a kind of an interesting intersection of a few different areas of computer science. It's an intersection of distributed systems research, programming language theory, type systems, runtime systems. So it's nice. There's if you're bored of one topic, you can always switch to another in the actor world. Should I maybe I should mention some examples of actor model languages and frameworks?
yeah, yeah.
Yeah. So probably what everybody's heard of most likely, if they have, is Erlang or Elixir. Those
Oh
are
yeah.
actor model languages. They pop up on Hacker News like all the time, and that's how I first heard of them. Even before I like really knew about actors, more people know about Erlang and Elixir, I think, than know about actors per se, because actually were kind of invented simultaneously with actors. So actors were coming up out of MIT, and actually they were with Carl Hewitt, and he was trying to do some artificial intelligence stuff. And this was like back when
Hmm.
MIT was doing the symbolic AI type of things. And then they were just got to a point where they kind of needed more computational power, and so they needed languages that were kind of more and more expressive. And Carl Hewitt had these very high-minded ideas about how we could do this type of concurrency, and he was just starting from the ground up, from first principles, coming up with these ideas. And then my advisor was one of Carl Hewitt's students, and my advisor helped kind of refine it into a very simple notion of what actors should be. And around that time, I think um, it was Armstrong. Oh, what was his? The one of the main basically the Erlang people were working in telecom, and they were trying to solve this problem of they needed some kind of programming language for orchestrating these distributed systems and dealing with all sorts of failures. And they were and ultimately they came up with almost exactly the same abstraction from a very practical um, we're trying to solve this specific problem point of view, where that my advisor came up with coming from a very abstract first principles. What do we need in computation in parallelism? So it's a really interesting kind of confluence there. That's in the actor world. That's our version of, the Curry Howard correspondence, probably the Erlang actor correspondence. Maybe that's some indication that it's a useful model.
Can you specify that isomorphism that you were talking about? Just it.
Like, make it a little bit more clear about what that isomorphism is. I mean, it's not a formal isomorphism. The point is that in academia, people were motivated by an idea of what does concurrency and parallelism really mean? How do we develop this stuff from first principles? And so that branch came out of MIT, and they came up with the word actors. And in the Erlang world, the company is called Ericsson. Ericsson were trying to figure out how to solve this precise problem that dealt with lots of various kinds of failures. And they landed on this idea of what they called a process. And their idea of a process, their abstraction, corresponds very closely to Gul Aga's idea of an actor. So there's a construct for creating an actor, and there's a construct for spawning a process. There's a construct for asynchronously sending a message from one actor to another. There's a construct for sending messages between processes. And so there's a very close, just it's like a similarity there, but it's not formalizable, right? But but it's an interesting confluence there.
Parallelism. Well, I think it's bad to use the word there's a parallel between these two worlds, but
there's a parallel,
so it's a bad word to use. But can you make a little more precise what does it mean to be for what is actually an actor?
Yeah, that's a great question. So an actor is basically a process. Whatever we have our idea of what a process is, we kind of know it from operating systems. But it's this idea of a process where it has a local state, it has a mailbox, and it has a unique address. And when an actor has nothing in its mailbox, it doesn't do anything. It just sits there. And when somebody puts a message into its mailbox, the actor wakes up and it reads the message, and then it executes a program to process that message. And that program, it can do several things. It can update its local state. It can spawn new actors. It can send messages to some actors. And that's about it. So that's the whole idea of what an actor is. It's just these processes that can do stuff. And I think more central to the impact that actors have is what they don't do, which is that they don't have shared mutable local state. So data races are not a thing in the actor model because you can't have shared data. And another thing is that deadlocks are very hard to have happen because actors are communicating by asynchronous messages. You can, work your way around things and cause things to hang or cause deadlocks, but locks per se are not a primitive in actors. So it's harder to get yourself into a deadlock type of situation. And I should mention, by the way, that actors, as well as being at Ericsson and being developed at MIT, they're kind of everywhere. It's such a simple abstraction. Based on my description, it seems like everything is an actor. You see them all over the place.
Yeah.
And you keep seeing actors getting reinvented by companies. Like I was looking into the Hadoop code base a while back because I was trying to find something about distributed systems bugs. And I found that they had developed these abstractions that I was like, they called them like services or something like that. I was like, oh, these services are kind of actory. And then I found a comment that's like, yeah, these are motivated by actors, actually. So it's just one of those things that just seems to be the right way to do things a lot of the time. It's just a very convenient abstraction that people keep reinventing. And besides Erlang, Akka, there's also Akka, there's Microsoft Orleans, the Ray framework has actors. That's a big machine learning framework nowadays. So lots of people are actually using actors for various kinds of things.
How do they communicate with each other? You said there is no shared mutable state and there is no primitive for locks and things like that. So I'm envisioning some sort of message passing style sort of thing and some sort of channel, something like that.
Yeah. So They just communicate by asynchronous message passing. So, and in order for actor A to send a message to actor B, actor A needs to have actor B's reference, or it's like unique ID. So if A has the unique address of actor B, A can send a message to B. And so, and it just sends it asynchronously. You just fire it, and then eventually, sometime later, that message hopefully will be delivered into that actor's mailbox. And so, talking about, how do they, so they can communicate by message passing and stuff, but you might say, oh well, this seems like a huge limitation. Like, how do I have shared state? Every program I write, I have two threads that need to somehow refer to the same thing. Like, if we're talking about a database, how do we talk about the same database? And the idea is, instead of having shared state that's in the form of like fields of memory, and then you can have data races for those fields, you just spawn an actor, and then we both have that actor's address, and we can communicate to that actor. And that actor receives messages one at a time, processes those messages. So it acts as kind of a natural synchronization point for any kind of shared state that you need to have. You spawn an actor, that actor has that state, and we can both talk to
That's pretty neat, actually. I like that,
him.
and again, make things pretty simple because then like the idea of state and the program, which is the actor, they're kind of like very intertwined, right? In the sense of functions and data is coming back together again, right? And that seems to be usually a good thing. I don't want to say that's always a good thing because that's a very dangerous thing to say. But you said
When you mix the functions with the data, sorry.
yeah, like functional programming, like everything's a function is the big logo, right?
Mhm.
And it's a good thing because usually it's a good thing because then things start becoming much simpler and it's less layers of abstractions, right? Things are getting more um, consistent, right?
Mhm.
But now you said a lot of really really good things and really good selling points. But what are the bad things? What are things that usually shoot the users in the foot?
Basically everything that I'm working on in my research. Uh, for example, the thing that I'm most excited about right now is my PhD research, which is actor garbage collection. So you know how in Java you create all these objects, blah blah blah, and actually, well, in pretty much every language, right? Python, Java, Haskell, you create objects, and then when those objects are no longer needed, they'll just be cleaned up by the garbage collector. Well, with the actor world, it becomes a lot more complex. For one thing, because actors can be distributed across different nodes in a distributed system. And so there can be, you know, nodes can crash, you can have messages being dropped. So that's one of the complexities. And another complexity is that actors, instead, they're communicating by these asynchronous messages. Whereas with objects, it's a much more well understood model where you just have threads that are working with these data structures.
Hmm.
And so, circling back, what's the problem of garbage collection? It's that you'll spawn an actor and it will do some work, and then eventually you'll forget about that actor.
Right.
Um, and then it might just cause a memory leak if you spawn too many actors. The reason you would spawn all these actors is to get lots of parallelism, because all of these actors can actually execute in parallel. So,
Hmm.
I have this big task. I'll spawn 10 actors and they'll each work on a part of the task. And then I'll get parallelism that way. But the problem is that eventually, I need to get rid of these actors. And in some cases, it's very easy to do. I mean, it's just like the memory reclamation problem in classical uh, in classical systems. It's just like the memory reclamation problem in classical
Yep.
systems, in that it seems like it's a very straightforward thing to do, to just clean up your memory when you're done with it. But we make mistakes all the time, and so we
Yep.
we create these memory leaks. Another complication, though, with actors is the concurrency. For example, I think that this actor has done its work, and I say, "Go, actor, you're done. I garbage collect you." But it turns out that somebody else, somewhere else in the system, needed that actor to be alive in order to do something, and so you can have these
Oh,
kind of races from doing this
right.
garbage collection. And so that's like a huge source of bugs. I don't have a statistic in front of me, but it's a
Yeah.
huge pain. Whenever I tell people like I'm working on actor garbage collection, they're like, "Oh, that's so great! That's so exciting!" Haha.
Yeah.
um, Yeah. So
Actually,
that's one thing. Mhm.
actually, one thing that is usually when I hear people working on parallelism, it's something that really makes me very excited because we don't realize that we don't have that much. Like with parallelism is a hard, very very hard problem, and it's very far from being solved. Right? It's if it's ever solved, and we don't. It's a really active field of research because we don't know how to do things properly yet, and there's a lot of open problems, and they're very very hard. I remember when I was starting the PhD, and my advisor was looking into some parallel programming problems, and I started doing some research there. I'm gonna confess, I got really bored about it because it's so hard that I don't even know where to begin looking. Right, like I would read these papers and I'm like, shit, what the fuck, what is going on, right?
That's
So,
how I feel about type theory.
oh come on, you work with languages, you're doing some stuff right there. It's not that bad.
I I actually wanted to do type theory when I started out in grad
Yeah, go on.
school, and um, but it was all Greek to me. I couldn't I couldn't understand what was going
Oh,
on,
but
so
it's
I kind of
literally
sank
all
into the actor
Greek.
thing. Yeah, yeah, no, I know that's the joke that I'm trying to make.
Uh,
It's funny that one of our best type theorists working today is actually he got his undergrad in I think like Greek literature or something like that. John
who?
Sterling, right? Did you know he had
Really?
like a
I didn't
classical
know that.
literature degree?
Hmm. Wow, that's incredible. He was.
Yeah,
We
I
were
know.
talking. Yeah,
I'm
before
so
this.
jealous of when somebody had the nerve to do a really cool bachelor's degree, like in like classical literature, and then they ended up in the same place or better than where I ended up. It's like I did all this terrible Python programming. I had to sort so many lists in undergrad, and you got to talk about Chaucer or something. I'm so jealous. Oh well, John is so cool.
That's another point about being in academia. You're always comparing yourself so much with other people that like we are surrounded by extremely smart and seemingly well, maybe it's a bad word to use, but we don't actually know the other people's struggles, right? We have is this shiny Twitter that nobody has. Well, okay, everyone has a lot of problems in Twitter, but we think we think everyone is like super cool, doing extremely cool stuff, and that everyone is so much more smart than we are. And the reason for that is because, like, I'm really not saying that Jonathan is not extremely smart, and I also admire him a lot, you know, but um, it's I don't know. I've been trying really hard to not compare myself with other people because that's a no gain game, like it always just makes us feel bad, and I don't know. You got my point, right?
Yeah, I mean that's a really paradoxical thing about that I found about our area is that we came into this area because we love the topic. We love talking
Yep.
about it and we
Yep.
love thinking about it.
Mm-hmm.
But there's a certain extent to which sometimes seeing people talk about it things very intelligently makes us feel kind of bad. And that's a we like that's such a
Right.
sad it's such a sad thing.
I agree. It gets to the point where like it's as if like it turns. Things are going great and everything is good and we're talking about great stuff, but there is a turning point where it just like starts getting dark, right? Like I love what I'm doing, I love what this is about, and then people start getting extremely smart and talking about things, and I start getting lost, and I'm like, oh my god, I'm lost, and I'm doomed. I'm really dumb, and I'm never gonna be nobody in this field, right? I don't know. It's just anxiety talking. It's tough to be in academia, but I think it's part of the process too, because as I said, we're surrounded by extremely smart people. And this thing that you were talking about of we're here because we love what we're doing. There's also one thing that we have to realize is that yes, we are usually, like we people in academia are usually very very passionate about what we are doing, yes, but you have to realize that now that you're in it, this is work, and work is not only a field of flowers. Work there's also problems with it. There's also, like the nasty details, the nasty parts, and you have to deal with like sometimes in the department there's going to be some people are that you don't want to deal with, and but that's also part of your work. So that's why I began this saying that we need to have other hobbies and other things too going on for us, because this is work, right? And as anything, when you do too much, you start getting tired of it, right? Have you ever eat a food so much that you cannot stand looking at it for like months, right? That sometimes research can be like that. I reached that point at some point. That's why I took a sabbatical year here in Brazil. Well, it's not a year;
Mm.
it was 10 months, but it did wonder to me, and I feel like I'm ready to come back and like be extremely productive and passionate again about what I do, because I know I'm passionate, right? I just got to a point where I ate too much of the same thing, right? I cannot stand it
Have you talked
anymore.
on the podcast about your sabbatical, about that process that you went through?
No,
Because I think that could be
you
really
think that would be
useful and
cool to talk
interesting
about
for
it?
people. I think a lot of people, I mean, everybody suffers burnout in various kinds of ways, and it was you, and there was another a PhD student from UBC. She recently also like took a brief sabbatical for herself. Do you
Was
know who I'm talking
it
about?
Paulette
Yes. Have you spoken to Paulette?
Karankovic? Yeah, she was my friend. Well, I hope she's still my friend. We were colleagues when we were doing internship at Galois, and we would sit next to each other. It was awesome because our people there was extremely um, friendly. We would hang out literally all the time. Every single weekend, we would be out partying. And Galois is an extremely amazing place. Yeah, I remember seeing that she also took a sabbatical. I don't know how long it was. I don't know much detail. I haven't talked to her much ever since. But what do you think would be cool to talk about it? What would you like to know about it? Let's
I'd like to
reverse.
know.
Let's reverse
Yeah.
things. You are now the interviewer. Go.
That's how I thought we were going to start things. I should have read out, "Welcome to the Type Theory for All podcast. I'm your
This
host,
is.
Dan Plyukhin." Yeah, so what I wanted
I
to
love
know,
this.
Pedro, what I wanted to know, Pedro, is how did you come to so I want to be careful about this question because it's obviously a very personal topic. At least I would assume that it would be. Is what were you feeling that caused you to want to take a break from the PhD? How and what did it take to like? There were probably times where you felt like doing that before and you didn't, and then there came to a point where you did decide you wanted to do that. And how did that happen? So that's multiple questions, but
Yeah. Let's go with it. First of all, thank you for asking this question. I usually keep things to myself because I feel like my life is not super cool. But one thing that I've been learning is that things can be pretty cool on my side too. And especially because maybe I'll get into more details later, but I'm Brazilian, right? And one thing that I learned outside of Brazil that we don't realize here in Brazil is that Brazil is pretty damn cool, and we don't realize it here, which is insane. But I've been I've been enjoying a lot my time here, and actually I've been learning things that I wouldn't have if I wasn't in abroad, if I wasn't out of Brazil. Okay, so coming back to your question, how did I come to this decision to take the sabbatical? It's a really hard decision. It's not something that you hear it often, right? Like you don't hear that a PhD student is taking a sabbatical. I don't think that's even the right word, right? Because I don't know what what is a
normally you
sabbatical?
hear
Is
the
it?
PhD student went and started a bakery instead. They just like blasted
Right.
out.
Okay, so I have to start by saying that COVID was really tough for me. It was really tough for everyone. Um, Maybe it wasn't. If I compare myself to other people, it wasn't that bad. But one thing that definitely happened was that I went through a burnout process, right? And maybe it was a good thing because it made me reconnect a lot with my spirituality. I've always been a very spiritual person, and like studying metaphysical things. I'm in a religion called Spiritism, and like we believe that there are some things that we receive communications from the dead and things like that, which is a really big thing in Brazil. But I was very like disconnected with my spirituality, and during COVID, I actually, when COVID started, I actually called my mom and I'm like, Mom, I want to come back to Brazil. I'm gonna pack things up and I'm gonna spend this time with you, with family, right? Because I was really afraid to be alone. I was alone one time in when I was doing an exchange in Australia, and it was so hard, and I was really afraid to be in that place again. I think I went through depression, but it wasn't. I didn't have psychologists to like go through that. You're gonna say something,
No, no, no. Sorry.
and then I was really afraid to go through it by myself, right? Because I would have to be isolated and pretty much just working. You couldn't even go out of home anymore, and I had a really old grandmother, which made me even more anxious. Like what is gonna happen? She's gonna get this disease, yada yada. I'm not gonna go through too much of that, but at the end of the day, I really started having panic attacks and like extreme anxiety, right? And then I
Wow.
started I started talking that's when I started therapy. That's when I started meditating. And the reason why I'm telling you all of this is because like it really made me reconnect and really appreciate the importance of mental health, right? Because without mental health, you cannot do anything. Without health, you cannot do anything. Health is like basilar. Without health, you you cannot like you cannot work, you cannot play, you
Hmm.
cannot talk, right? And mental health is health. So that made me really really value health. Okay. That being said, I was actually like I started then really really crushing through my research, which I have plans to talk a little more about it in a second. But basically, I'm doing some stuff, like with compiling inductive data types between languages, which I actually think from the bottom of my heart that is extremely extremely cool thing to be doing. I really love what I'm doing, but as I mentioned a little bit ago, I've done it too much, right? Like there would be some days that I would work 8, 9, 10, 12 hours a day because I wouldn't feel that I was productive. So I just kept crushing and pushing and pushing. And the one thing about doing home office is that you don't realize how productive you are being, right? Because when you're in an actual office, you take breaks, you talk to people, you go out and you have coffee, you take a lunch break, right? When you're doing home office, it's like, for me, it was work, 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 lunch, work, 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 right? And like I would look back, wow, Monday I was this much productive. I have to be productive again this much on Thursday. And what I wouldn't realize is that no, you cannot. There's only so much juice you can get out of this lime here, right? So I started I really started like losing this feel. And it was more than a year. So there was 2020 when all of this was happening. There was 2021, and I really like for a whole year I started feeling very very unproductive, and I'll try many many things, and I wouldn't get this excitement out of my research anymore. I tried many many things. I tried to I probably edit some of these things out because I think it's already started being boring. But the important thing is that I tried a lot of things that I thought could help me with my productivity, because at this point I really thought, okay, now I'm really not being productive, right? I think like I was getting 1 or 2 hours of work done a day, right? That's really really little, and I wanted to do more, and I tried many things to do more, and I couldn't. Like I I was done, right? So as I said, I added meditation in my routine, and it was really good because it really helped me to relax and to clean my mind, and I learned many many different techniques. But one day I was sitting down meditating, and I was extremely frustrated with the quality of research that I was doing. And again, I was really happy with what I was doing, but I was frustrated that I wasn't getting out as much as I wish. Right? I know that I could do better, right? And I was not even trying to compare myself with anyone or anything. It's just like my own measures. I wasn't satisfied with how things were going on, and I really felt that I really tried everything that I could. I tried really everything that I could to change the situation. So I took a really really honest look into myself, and I did this following question: if you could do anything you want at this moment, if you forget about your mom, forget about your advisor, forget about the world, forget about money, forget about literally everything, everything, what do you want? And only one thought came to my mind. I wanted to be on a waterfall in Brazil. That was it. That was like as bright as a very shining light in the middle of nowhere. I knew that this is what I wanted, right? And that's the beauty of it. Once you know what you actually want, you just have to work through it. So I literally just stood up and I went to a website looking for, can I take a time off for my PhD? And I figured out that I can take 2 semesters off. Blah blah blah. Send some emails, and I made it work. And I came to Brazil. I had some money, some reserve, and that's how it came about. And it's really been one of the best things I've done for myself, really. And it's really hard. It's really hard because it's a hard conversation that you have to have with your advisor, right? It wasn't easy because I know that he has expectations on me. He's not a tenure track, and I would have to call my mom and say, "Hey, mom, I'm coming back home. How do you feel about it?" And I really feel like I was failing, right? Like telling that I was failing, but my mom's just so magnificent that she was just happy. She was just, if that's what you want, yes, come. I'm very happy that, and she understood. She knew what I was going through, right? She knew what I've like my struggles, and maybe not many people talk about it, but living in another country is not easy. Even in another country, you're always outside of your comfort zone. You're always learning. You're always, like, it's not only about another language, it's about another way to talk and treat people. It's another way to, like, how we say hi in Brazil to people? We hug. If it's a boy saying hi to a girl, we give a kiss in the cheek. What day on earth is that gonna happen in the US? I'm literally afraid of hugging people in the
That would
US.
be your last day in the US before you get deported.
Dude, some days I literally feel like, okay, that's it. Today I'm gonna be arrested and I'm gonna be deported. Right? Dude, I have some really funny stories about things, like cultural shocks, like it's cultural clashes, maybe it's the right way to put it. Because things are just different, right? And you know, just that that's how I lived for 4 years, and you just start getting very tired because, dude, I just want to chill, right? I just want to come home. I just want to have friends and relax, man. I just want to relax. So coming back home, I can do that. I know what I know what is the expectations. I know how to behave. I know how to do things, right? I can relax.
It's been really inspiring to me seeing, well, inspiring and also making me really jealous to see you on Instagram, like every now and then, like in front of a waterfall. I'm like, why? Can he be a little bit less satisfied with this decision? But it seems like
Yeah.
you really,
Before
like
we continue, let's
you uh,
let's zoom in. Let's zoom in that feeling of the waterfall for a second because I really want to share this. But the
mhm.
day I took a month to live in a place near here. I live in Brazil, right? I took a month to go to the woods and live in a place surrounded by waterfalls. There are probably like 100 or 200 waterfalls in like a 100-mile radius. It's an insane amount of waterfalls. So I moved there. I rented a place for a month, and I was hiking every other day, like 10, 12, 15 miles a day. And the first day I went out and I went to the waterfall and I felt the water. It's an extremely cold water in an extremely hot day, and you're very tired already because you hiked a lot. So like imagine you are walking for 1 hour and then you see this water going by that is very very cold, and like the sun is extremely hot, and like you're very hot, and you pick the water and you put your head on it, dude. I literally felt that all my problems in the world was gone. All my stress was taken away from my soul and just took down that river, right? And I actually cried this day. So much relief and so much happiness for doing this decision, right? So yes, I couldn't be any happier with it, and I wanted to
That,
share it.
that's really beautiful. I love the way you put that whole story. I'm proud of you for having done all that, and you're
Oh,
still
thanks, man.
standing. You know, like everybody, it feels like it's the end of the world, right? When you were contemplating this, what's going to happen? What's my advisor going to think? What are my parents going to think? And here you are, and you look great. You know, you're happy, and you're coming back to the States in a month, right?
I am, but I went through a lot of inner work here. I found myself in a way, and it's crazy. But at this point, like I said, that I was in the woods, like living close to the waterfalls. And at this point, I was waiting for the result of a submission that I had on CPP, certified programs, certified Papillion programs. I don't remember. And and to my demise, it was rejected, and it was really really tough for me this day. I really didn't expect, because like I put so much work, I put so much effort, and at this point, I I had to face a really hard decision in my life, because I I had to come back to the US, and to finish the PhD, I pretty much would need three more papers. That's kind of like the expected, right? And this is my first paper, and it was rejected twice. And the reviewer seemed to have liked it even worse the second time. Like he asked for a lot of revisions, and I have to come back to the US and put one more year of work into this, and not know what's going to happen. And that really freaked me out. That really freaked me out. And I had to find what I wanted to do at that point, right? And what I found that I wanted to do is that I'm really unsatisfied with the place that I'm at. So what is the path forward? Um, it's not only about the research, but like I think I realized I don't really feel the US. I think the US is too much for me. People work too much, man. It's just work, 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 work. People even like put work in front of their families, work in front of their friends, and that's not me. That's not me. I cannot do that. I cannot do that, and it's impossible for me to not compare with the other people around me, because I will literally feel that I'm not, like in this environment, I feel that I'm not enough. I really feel like I'm not enough, because everyone is putting more of their skin into the game. It's like they have more into it, but this is not me. This is not me. So the decision that I made was that I would go back to the US, and I would just finish a master's, because I don't have a master's yet. I'll finish a master's and find something else. So I actually have huge news for my listeners, if he could survive all of this. But I am planning to do some, like after the masters, I'm planning to invest a lot more in the podcast. So there will be a lot of really good news coming up. Stay tuned.
Possibly merchandise.
I actually looked into it, and merchandise was actually really hard for me to do because of some bureaucracy in Brazil. And like I actually started studying some drop shipping stuff, or blah blah blah. But did you know that I'm on an F1 visa in the US, so I cannot actually work. So I cannot actually monetize my podcast there while I'm a student there. So when I come back, I cannot, like I have to. Um, but I have plans to eventually start doing some actual merchandise, like shirts or those sort of cool things, pens
Mhm,
and notebooks. It will happen. It will happen eventually.
mhm. So now, Pedro, as your second question on my podcast, I understand that you've been doing some research on inductive data types. Um, can you tell me a little bit about why you're a good person to talk about inductive data types?
Okay, so here's the thing. I've been doing research in inductive data types since COVID, since a little before COVID, and it was really fun because, well, it was actually sad. I was extremely excited to go to France to do this part of the research because Nomadic Labs had hired me and I was traveling to Paris. Everything was worked out, but COVID hits and I'm stuck in the US for the summer. And I worked on it since ever since, right? Like for 2 whole years, a little bit more. So our goal there was this. I actually talked a little bit. I think it was the first episode. It came out the end of 2020, and the work I was doing is to translate part of OCaml to cock. This is really exciting to me, as I said multiple times, and I'm saying again. But the in particular, we wanted to translate GADTs, generalized algebraic data types, from OCaml to cock, and this was particularly hard because of how types are different. Like the structure of types is kind of different of how they work in OCaml and how they work on cock. And there wasn't a really, like clean solution on how to do this translation from OCaml to cock. In particular, pattern matching, like in the presence of GADTs, you can have these things called impossible branches. In OCaml, some branches of your pattern matching are just impossible, and you can literally not write them down. You can literally elide them. And it's a really cool feature in OCaml, and that's used a lot in this code base that we were trying to translate. And there wasn't a really clean solution on how to do this translation, right? So this is what I was hired in, and I was a good fit because before this I was doing some translation from Sadil to Cog with Aaron Stump and my advisor. And actually this there was this project that I started doing called Cockadoo, and I was working on it for at least a semester, and I was putting a lot of thought into like translation of pattern matching already before I was even hired, right? So I talked to them and we thought that this is something that we could work together to find a good solution for this. So I spent probably like a year doing this, like trying to find a good way for doing this translation. So
Could you
uh,
talk a little bit about why you couldn't do this exhaustiveness checking? It's exhaustiveness checking, right? Why you couldn't do
yes.
exhaustiveness checking in cock?
Yeah. Yeah. So the thing about cock and the thing about OCaml, that there's a key difference of how things work there, especially type checking. Like because OCaml type checker has much more information than Coq. Coq is very conservative about like inferring that two types are the same or not. Like very very conservative, and that's a good thing because of that you can do things like homotopy type theory, which we can maybe touch a little more later. But the key here is that it's not, like you really really need to be very sure that two types are the same for Coq to agree that two types are the same, right? So you really have to convince Coq. You have to do a lot of convincing for Coq to agree that two types are the same. And the key thing about JDTs is that, okay, so let's talk about JDTs for a second. JDTs is a kind of ADTs, and what is ADTs is algebraic data types. Don't get confused with abstract data types that sometimes also go for ADTs, but we're talking about algebraic data types here. And algebraic data types are basically a way to build a new type, right? And how you build this new type is with something called constructors. And in order to do this cleanly, you want your constructors to have a couple of properties that I'm not going to get too much into details. You can look on Cox PhD thesis, which I extremely advise if you're interested in this because it's actually pretty well written and very understandable. But you want your constructors to have some key properties, and the key here is that with regular ADTs, all constructors are going to build the same type, right? It's going to build a type. But with GADTs, your constructors can build different kinds of type, right? So you're not actually defining a type, but you're defining something that is called a type family. And it's as if you're in this type, you're putting a for all at the beginning, right? So instead of defining T, you're defining for all X, T of X. Something like that, right? It's actually a function. It's actually something that once you provide me what this X is, now I have this type that you're building. And that's the key about JDTs is you're gonna ask?
Well, so it's a type that's parameterized by another.
Yeah. Type.
Uh-huh. But it's not like in Haskell where or OCaml. Well, so OCaml has and Haskell, they both have GADTs where it's like list of A, and it's just for any A you can have list of A.
That's a
With GADTs you can have some A's are you can't have, for example, or how
So
does
the
that work?
thing, the thing, the thing about lists is that the type constructed by the constructors are still symmetrical. They're still building the same list. All of those lists you're building are lists of A.
I'm not sure I quite follow that. Can you
Think
can you give a
think a
specific
little.
example of a GADT? Would that help?
Well, yeah, of course. For example, you there is a way that you can define a vector with JDTs,
Hmm.
and why is that?
Where a
Is
vector
because
is a finite list.
so in the vector, you just by looking at the type of your element, you know exactly what the size of the list is.
Okay.
That's what a vector is. So it carries around the size of your thing, right? It's a list indexed. It's indexed by its size, right? That can be done by JDT because there is a way that you can do the piano numbers in the type system, right? You can say that s of o s of something is is a type, and also o is a type, right? So you can parameterize by those two things, right? So you can count
Hmm.
the amount of s in the type of your
So your
vector.
your type would say this is a vector containing 5 elements. That would be
Yeah.
the type. Okay.
Yes, that would be the type. Exactly. Another really good example of a JDT is expressions that carry what are their kinds, right? So let's think about an expression that has like um, booleans and numbers, right? So an expression like that can be, here are the constructors of my expression. So the first construction say that the expression can be true. The second one says the expression can be false. The other one says that the expression can be a natural number. And the last one, I don't know, like you could, well, one more way is that you could have an expression that takes two other expressions and do their their and the other one could take their, or you could have an expression that is a sum, that is a multiplication, things like that, right? Like a small little language, right? That does some funny things. The good thing about JDTs is that each one of these constructors now can carry around what kind of expression you're building, right? So for the constructors that build boolean, you could carry around and say that now this is an expression of boolean, and some functions can only be, you can only work with expressions that are boolean, right? So um, and other functions, you could just work with expressions that are natural numbers, right? That that inside there can only be natural numbers. So on the type system, the only way you could build sum, like the constructor sum of an expression, can only take two other expressions that are already expression of natural numbers. So there's an extra another layer of type safety that you can have on the level of type checking, right? When you're building your expression, you can only build it if it actually makes sense, you know. So JDTs is a great source of, we call it, how we say is that it's a great source of lightweight formal verification, right? Because you don't have to go all the way down to cog. but you can gain more guarantees out of your type system with JDTs. And that's really
Mhm.
cool. Now, let's go back to your question. The original question was, why is it hard to do this translation? Okay, now we understand a little better what JDTs are. And if you're still a little confused, I suggest that you pause it and go to a Haskell or OCaml tutorial to look at JDTs now. But it's not super necessary. I think the argument here can be made either way. But the key here now is to realize that your JDTs they carry around some typing information, right? So as I said, is an expression of something, right? So there's this of something is a typing information, right? And the, the the key issue here, the heart of the problem in doing this translation now, is because every one of your types is very in OCaml. It's very easy for you to discriminate between types. It's very easy for you to say that net and boolean are different. It's very easy. It's very easy because all that the type checker has to do is like, is it the same name? You're done, right? because because they're gonna be treated different because there is gonna be a different way they were defined, and therefore they're done, right? But in Coq, this is not the case. This cannot be the case because, as I said, things like homotopy type theory would make no sense, right? Because okay, um, now in order for you to convince the type checker that these two things are different. Oh, sorry, let me take a step back a little bit. Why is it important to discern these different types? Is because, okay, do you remember that I said that some functions now can only work with booleans, right? Some functions can only work with expression of boolean, right? And everything that is not an expression of boolean you can ignore. So when you're pattern matching there, you don't even have to talk about expressions of natural numbers because when you're pattern matching, you say, okay, my x is an expression of boolean, and I'm pattern matching this. So the only constructors that make sense are this, and this because they will construct an expression of boolean, right? And you can literally ignore your expression of natural number. And why is this possible? Because when you're building this exhaustivity, the type checker is going to look, is net equal to boolean? No, you can ignore it. So that's the key. That's the heart of the issue. That's the heart of the issue, is doing this type checking on the exhaustivity of your pattern matching. And I wanna make a parenthesis here to really talk a little bit about exhaustivity and how exhaustivity is very important, because this is something that bothers me a little bit in Haskell, for example, because maybe I'm wrong and there are ways to get around with it, or maybe it has changed. It's been a while I don't use Haskell, to be completely honest, but last time I used it, exhaustivity was not on by default, and this really pisses me off. This really pisses me off because you're literally throwing away a really important part of your type checking. This is literally type checking your pattern matching. This is exhaustivity is type checking of your pattern matching. If you turn it off, you're throwing away part of your type checker, right? So you're throwing away typing information, and and I don't like it. This is the whole thing I'm doing is like to gain this sort of thing, and Haskell just throws it away. Again, maybe I'm wrong. Maybe this has changed, or maybe I'm bringing this up from my head. Please, if you're listening to this, let us know if I'm wrong. But okay, let's go back. So this translation now, you're starting to understand why this translation is so hard. Is because in OCaml it's hard to discern between these types, right? In Coq, so here's the thing. In Coq, you can prove that NAT is different than Boolean. But in order to do that, there is this cardinality argument. Like you have to show that they have different number of elements. You can do it. Yeah, you're doing a very expressive face, but you can prove it. But it's not
No,
all
I'm
the
surprised
time.
that you have to, in order to show that nat is not equal to bool, you have to reason about the number of elements. That's an
Yeah.
incredible roundabout kind of way of doing it.
Well, how else would you prove it?
Well, one's got true in it, and the
What is
nat doesn't
true?
have true in it.
Hmm.
But I guess that's the way that Coq allows things to have multiple types. Is that right?
Well,
Pres-
now things are starting to get really interesting, because the heart of the problem now is an even more hard problem, which is equality. The more you look into equality, the harder you notice it is. Like, it seems like very, very trivial at first glance, but the harder you try to put your finger on how trivial it is, the harder it is to do that, right? So, um, you have to be when we're talking about this level of type theory going down to equality, you have to be really, really precise what you mean by equality. There are many different ways to define what you mean. Like, there is Leibniz equality, there is functional extensionality, for example. There there is propositional equality. There is heterogeneous equality. There is there are different ways to talk about what you mean by things to be equivalent. What do you mean by things to be the same, right? And when we're talking about types, that gets even harder, right? It's really hard. So it's so hard that there was a PhD student that is now a professor, Jasper Cox, that his whole PhD thesis was to turn off one axiom used in type checking pattern matching in Agda, and this is called the K axiom. And his whole PhD thesis is to not rely on the K axiom in order to actually do this type checking of pattern matching. And why is this important? Is because the K axiom is incompatible with homotopy type theory. So and again, homotopy type theory, as far as I can understand, the main concern about homotopy type theory is equality, right? It's paths and is how things are related to each other. So his whole PhD thesis, which again I recommend the user interested in this to read, is to turn off the K axiom from Agda and be able to do all this. And what the K axiom is doing is really truly, like, um, turns out that the K axiom is equivalent to this other axiom called uniqueness of identity of proofs, which pretty much is saying that any ID, any identity, anything that goes back to itself are the same. Any loop that you can do to go back to itself, any x equal x are the same proofs. All these proofs are the same. It turns out that this is not good in homotopy type theory, because in homotopy type theory, like, there are many ways you can construct this loop, right? There is a transitivity from x to y to z and z back to x. This must be different from x to x, because like, these are different paths, because it has more arrows, things like that. So, okay, um let's go back and see if I answered the question. The question is why translating pattern matching is hard. Was that correct?
I think my question was, um, yeah. So why can't the whole point was about exhaustiveness checking, and why can't you get exhaustiveness checking in Coq? And I think the explanation was that in order to do exhaustiveness checking, you need to know if type A is equal to type B, and you can't
Right.
do that in Coq.
You
Okay.
can, but you have to provide that proof. You have to do
Oh yeah,
that
you
proof
have to
manually.
prove it. That's the hard thing.
Right.
So
Right.
so
Right.
kind of
And
as long as we had an amazing mechanism that could, for any two types, tell you if those two types are equal or not, then the problem of translating OCaml to Coq would be solved.
kind of, because you still have to provide that proof, right? You have to actually
Yeah.
still, during the translation, you have to build that difference, right? And this is
So do
this
you
is
guys have
also
to construct that proof? Is that what you guys did?
yes, but we were smart about what we had to do along the way. So now it comes to the solution. And what happened is that, so the hard problem is to prove that two types are different, right? What
Mhm.
if what if I just have to prove that two values are different? That's very different. It's subtle, but proving that two values are different is easy, right?
Interesting.
So
Is it
the
okay?
key here is to be smart on how you translate the indexes of your GADT, right? So one thing that I wanna stop a little bit is to draw the difference between an index and a parameter in a in an inductive data type. So A parameter is like that A in list that you said. The parameter is when you have something that is abstract, but all your constructors are gonna build a type with that A, right? All of them are gonna build a type with that A. An index is when at least one of your constructors are not gonna build this A. Is gonna build something else. For example, an int, right? So this A now cannot be a parameter because not all of your constructors are building the same thing, right? Your parameter, all the constructors
Oh, I see.
have to be of this type C of A, right?
Okay.
This C of A. Okay, so now we're talking about indexes, right? What if all my indexes are actually value, right? If I know what are the possible cases that my index can take, right? So in this case of exp that I was talking, the only indexes that this exp can have is net and bool. So what if I have a data type that describes exactly that that the first one is int and the other one is expression is a bool, right? And turns out that's a lot easier to do because now proving that the constructors of these data types are different it is easy because this is, you remember when I said that your constructors, you want them to have certain properties, the property that the constructors cannot be the same, each one constructor must be different from each other. This is a key property that you must have to have good pattern matching, right? Because otherwise all your pattern match would be this, like would go down to the same thing, right? So that's kind of the idea that I tried really hard for a year to work on, is how can I change the indexes of my data types for something that is better behaved. So okay, um, how can I change the indices of my data types to something that is better behaved? So it was a lot of back and forth, and then I think I finally came up with a somewhat clean solution. I'm not extremely happy about how things came about, but it was tricky. It was tricky. But the key here is that is to change the index to not be indexed by any type. You want to constrain how it can be indexed so that you know how things can differ there. So that was the key. We changed when we noticed that we were translating a JDT. We changed this index to something better behaved, and
Mhm.
then when we are translating an inductive data type, and then when we're translating a pattern match, we translate the body of the pattern match in a smart way so that you embed the proof of how this index now can differ, or sometimes you also have to cast things to their proper position depending on how things are going. So that's the idea. We change the index of the data type, and then during pattern matching we embed, we go there and we do a little proof there in line. We line a proof there with some L tag, like it's a nice little strategy to make things type check cleanly, and we implemented all
So
of that.
I have three questions. One is this a paper that's been published? Number two, we forgot to mention what is the motivation for why you want to do this problem in the first place. And three, a tangent, but I'm very interested, is why is it hard to tell that types are different but easy to tell that values are different?
Mm-hmm.
And if we talk about the motivation for the OCaml stuff, you could explain it and then move it to the beginning of the discussion, because I just realized that if anybody's listening, they're like, wait,
Nah,
why is he doing this translation?
nah. This is something that I've been thinking about lately.
Uh-huh.
Actually, there was someone on Twitter the other day saying that he would like to see papers that better explains the motivation of why they're doing this type things. And I wanted to talk about it for a second. I honestly think that we should be less concerned about motivation when we're doing research. Research is supposed to be, like just researching things. That's how math works, right? I know that some people will disagree, but this is my personal view. I think research should be done by the sake of research, and that's how things go forward. If you are interested or you're curious on something, you you should be able to do research on this, because you'll never know what is going to spawn out of it, right? But okay, but in this particular case, there was a company doing some work for Tezos, and this company is called Nomadic Labs, and they were actually, so all this JDT stuff that I was talking about with this express, they were actually trying to translate some expressions in the what's the name? They had this smart contract language, and they have an interpreter for this smart contract, all written in OCaml, and they wanted to do this translation to Cox so that they could reason about it. So that's actually a pretty strong motivation. And in the paper, we actually show how our translation could actually translate a couple of new data types and a couple hundreds new functions, right? That was pretty cool. But
That is
yeah,
really cool. You should
hmm
include the link to the paper in the show notes, or
it was
say what
rejected.
the
There is
paper
no
is.
paper.
There's no paper. What are you talking
There's no
about? But this
paper.
is
It was
really cool.
rejected. It's not an archive. Well, tell that to the rejectors, man.
Oh gosh.
Oh, it's cool, but it's not enough, right?
I
There are
I
key
totally agree
things
with you about this
missing.
motivation thing. I mean,
Yeah.
it's such a pain. I mean,
Well, so here's the
it's
thing.
one of the things
Not
that
only
takes the joy out of. Yeah, go ahead.
not only I implemented all of this, but I started doing the actual proofs of why all of this works. And I'm not gonna say it's the best proof, and I agree with the reviewer that there are some open things here and there, and these proofs are can be very messy. They can, but yeah, um, I have some actual proofs, and some of them are a little messy, but
As
things should
somebody
should
who's
line up.
currently
Yeah.
writing a thesis that is just a total nightmare of proofs, I have developed a philosophy that proofs are only going to get harder. It's the 21st century. We've done
Yep.
all the easy proofs. It's just going to be
Yep.
garbage, horrible nightmare proofs. Things that are true for absolutely no reason, and some grad student
Right.
just
Yep.
did out all these steps. They did it in
Hmm.
Cox, so
Yep.
you can kind of trust them. I think yeah,
So
that's a
there.
weird thing. And for a long time I was really impeded in my productivity because I thought I had to get everything perfect. I had to find people talk about proofs from the book. Have you heard about this? It's like God has a big book of proofs somewhere on his shelf.
What?
And if somebody
Well,
says that this is a really great proof, they'll say it's a proof from the book, from God's book. And I thought like every single theorem, it should have a proof that's in the book. It should have a perfect, beautiful proof. And then I've decided in order to graduate, I needed to shake that that belief from my
I
mind.
thought. Hmm.
Yeah.
Actually, this was something that I was thinking the other day, because there is this, like, um platonical approach to the abstract realm of mathematics, and how things already exist in this beautiful realm, and we're just discovering math, right? And
Especially
the
in
other
type
one,
theory.
and the other people, they think that no, everything that we're doing, we're inventing it on the go. And I've put some thought into it, and I believe that my personal belief, currently, is in the middle. Is right in the middle, because I think part of it, yes, we're discovering, and part of it, yes, we are just we're just like crushing the button to make things type check, right? Because here's the thing: a lot of how things are put forth, it requires a lot of creativity. It requires, like, coming up with a language. Coming up with a language requires creativity on how you're gonna lay out your things, right? But then once you set the game, once you set the language how you want it to be, then you're really constrained on how to do the proofs, and how to do the type checking, and how to do things. That's the discovery part, right? But really coming up with the rules of the game, that's the discovery. That's the creativity part. And I think math is really both, because what how I see math is just this huge monopoly game, this huge board game, right? Just a set of rules made up by mathematicians, that we just play them out. So we take the axioms that we want to work with, and we play them out, right? But the key here is realizing that you can choose whatever axioms you want, as long as they make sense, right?
Mhm.
And this is the beauty that we got, like, non-Euclidean surfaces, right? They just got rid of one of Euclid's axiom, I think the fifth one, something like that. And they're like, yeah, We don't want to play with this axiom anymore. Let's change it. And then they have a new set of math, and that's a whole new game to play. And that's what Einstein used for coming up with the theory of relativity, right? Isn't
Yeah, I
that
think that's one of the
beautiful?
most beautiful things about logic or whatever that I learned is that it's really you choose some bricks. You've got a brick that's shaped like a square. You've got a brick shaped like a triangle, and all of your proofs are built from these particular shapes, and you
Yeah.
just make
Yep.
towers of them. I think that's like
Hmm.
the key insight of that Jensen style proofs, right? Is that it's
Right.
just brick by
Right.
brick. Yeah, it's kind of an interesting idea, but it's also kind of an aromantic idea. Like you said, like it's a little bit less than the Platonic idea
Right.
of what
Yep.
proofs are, but nice from a computer science perspective, I guess.
That's the thing.
Everything is just
Often
trees.
enough, it's just like crushing the numbers and trying to get things done. Right. It's just putting things together. Right. And that's where computers are gonna really shine. But a lot of it, I believe, is the creativity of putting the pieces together and saying, okay, this is the game we're gonna play. These are the axioms that we're gonna play by. And I really think that's a work of creativity.
I like that this podcast is shaping up to be a very like kind of meta. What is it like to be a grad student? What is it like to do research and be burned
What
out?
is math, right? We got
What
we
is
got pretty
even math?
deep. But okay, let's go back to your initial question. There were two others, and the first one that we just answered was that, okay, why is this a cool research? The second one was,
Oh, I wanted to know what was the name of the paper, and sadly, it's not possible to find this work. Is it
nope,
possible to find the work? Oh, that's
nope, Mm-mm.
God.
Doesn't exist
Well,
other
that's
than my
so.
hard drive and my cloud.
Please
I'm actually
DM
thinking,
Pedro if
what
you're
I can
if you
do
need
it.
this work.
No, don't. I'm not giving you.
Yeah, they'll just try and publish it. That's so sad.
I will. No, 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 no. I'll make it my master thesis. This is literally my master thesis we're talking about right now.
Oh, okay, okay.
So I'm gonna really polish things up and really, really explain things detail by detail, and you're gonna be able to read it in a very crappy English from a Brazilian. Good deal, right?
I can't wait to see it. I can't wait to read it.
Awesome.
And my third question was about why is it hard to tell types are different, but not hard to tell that values are different? And I think that that's like a whole spin-off conversation
No, it's
that we
not.
may or may not talk about. But if it's, I think
It's pretty
one of the things
straightforward.
when I was getting interested in type theory, I think I had a very hard time figuring out where the results were. What are there's a lot of type theory that is kind of like sort of implicitly taught
Yeah.
through
Hmm.
one thing or another. And I think
Advisors.
this
Yeah.
idea that it's hard to
Part of
tell
the
values apart.
folklore. Yeah.
Yeah, yeah, yeah.
They say
There's like a
they say it's
lot of
part of the
folklore.
folklore. Yeah.
Yeah. So I think one of the most helpful things to do is to provide more resources like that to say that look at this
Yeah.
paper, look at this, Google this particular search term. Anyway.
Yeah. And that's honestly what it in my point of view, it's what you get the most out of grad school. Is literally going through that and being advised by someone who's been through that, because some things are just, like mouth to ear knowledge. And it's honestly, I think that's okay. It's not a bad thing. I think it's a good thing. Not necessarily a good thing, but it is part of the process. It's part of how knowledge is built, in my point of view.
Yeah,
Because it's
it's
part of a
how humans
philosophy. It's
work.
part of a school. Yeah, exactly. It's part of a school of philosophy. Like an advisor is teaching you how he thinks, and part of how he thinks was taught to him by how his advisor thought. So it's like this lineage of how to look at things and problems, and I think that's really beautiful. And okay, so coming back, why looking at values is much easier than looking at the quality of types. And one thing that we have to realize is that we're talking about CIC here. And what is CIC? Is calculus of inductive constructors. What does that mean? It means that it's COC with inductive data types. And what's COC? It's calculus of constructors, which like is just lambda calculus on huge steroids. Fun fact, I usually say steroids as asteroids, and Americans get really weird. And I'm like, why?
Oh, my dad is a Russian mathematician, and he pronounces matrices as mattresses. And he teaches undergrads. He's like, we're going to
Now
learn
I
about
understand.
linear algebra and mattresses.
It took me a while to get that one. I was like, okay. I think we're gonna sleep a lot in his class, huh? That's funny. Okay, so we're talking about CIC inductive constructors, and what it means is that in order to build terms of particular types, we use something called inductive data types, which is the CERN of all this that we're doing, right? And in order for inductive data types to be well behaved, I mentioned a couple of times that it must hold a couple of properties. Two of them is injectivity and conflict. And what conflict does, you really want conflict. You really need to have conflict in order to have pattern matching. And what is conflict? Conflict is saying that any two constructors are different, period. If net has O and S, you must have that axiom that O and S are not the same. Otherwise, when you're trying to pattern match, you wouldn't pattern match. Like there wouldn't exist in pattern match because you could not differentiate between them, right? That's what pattern matching is doing, is discriminating between your constructors, right? So this is exactly the reason why it's easy to differentiate and prove that two values are different, because constructors are how we build values in CIC. Period.
But types aren't constructors. They're defined in terms of collections of constructors, right? So
Yeah.
I'm just like trying to connect that to the idea of types being hard to compare with one another. And
Yeah.
I guess I'm coming from like this very like basic Haskell 101 understanding of what types are. And I think of a type as like Boolean is it's got true and it's got false and it doesn't have anything else in it.
Well,
And
but here's
true
the
does not
thing.
equal to 0. So true Boolean is not equal to nat.
Well, but all I said is that there are a couple of layers on this, and this is actually a pretty good question. I'm not sure if I'll give a good answer, and I'm not sure if it's the right answer. However, one thing that we have to realize is that I said I was talking about conflict where constructors cannot be the same, right? But I didn't say much about constructors on different types, right? I didn't
Uh-huh.
say that
Ooh.
that O has to be different than true,
Oh,
because think about
that's
it.
really interesting. It's not necessarily?
I don't think so. I can be full of shit now, but think about it. Yeah, think about it. If you have bool that is made of true and false, and you have bool prime that is made of true prime and false prime, can you say that true is different than true prime? I don't know. You probably can, right? But can you say that bool is different than bool prime because of that? Can you see the problem? They're actually the same data
Uh,
type, but with different constructors, exactly as you
mm.
said, right?
They're isomorphic. Hmm.
That's
Okay.
the whole point. That's all we're talking.
Yeah.
That's all we're saying. Like,
Uh,
are these doing the same thing? Are not doing the same thing? What does it even mean for them to be the same, right?
yeah.
Having different
Interesting.
names suffices here, maybe, I don't know. But if you're talking about homotope type theory, where all of this, like, you really need to carry about how these things are actually constructed, then yes, that makes a lot of
Mhm.
difference.
That makes sense.
I think that was what I pretty much wanted to talk about on inductive data types, unless you have more questions. But one thing that I wanted to mention is that this is a little trivia, but according to the history of Haskell, it's a paper that appeared in the history of programming languages, the Hope. Like, there's this really cool conference that happens every 5 or 10 years. I'm not sure. It's called Hope, the History of Programming Languages, Hopel.
Hopple,
And
yeah.
according to one of the papers that Haskell submitted talking about the history of Haskell, Hope, a programming language that was developed in the 80s or in the 70s, but the paper came out in 1980. Uh, is supposed to have been the first programming language to have invented ADTs, which I think is pretty cool. So the name of the paper is Hope, an Experimental Applicative Language. And they would call it's interesting that they didn't say functional programming language, they would say applicative programming language, which seems to me to be something that really changed on time. We never talk about applicative programming language nowadays. That's curious.
Huh. Would APL classify as a
I have no
applicative
idea.
programming language?
No idea. I know that Lisp would be applicative because it's kind of same idea
Uh-huh.
back
Lisp
then.
ML.
Yeah.
You've got acyclicity in here in the notes, but
Yeah, well,
hmm.
yeah. So this is going a little deeper on the properties of constructors, and constructor also have to be. Um, you also want your constructors to have two more properties. I talked about injectivity and conflict,
Hmm.
but you also want induction and acyclicity. And well, I was actually trying to think a little harder on this. Why you want induction and why you don't want acyclicity, and they're kind of related, but well, now we're really stretching my knowledge here. But acyclicity is important so that you don't have like non-ending data types. Like you could just you would have actually some sort of stream instead of a data type, a finite data type. Like you could keep going forever, and your type checker wouldn't know that you could actually hang your type checker in a loop, right? If it's cyclical, and you cannot have that because one thing you need your type checker to have is to be terminating. You really need your type check. That would be really bad. You're trying to type check your language and it just halts. That's bad. You need it to terminate.
Okay. Tagged onions and why you think they're unreasonable. What do you have against tagged onions? I personally think that all onions should be labeled.
No. I agree. All onions should be all onion. Oh my god, I'm thinking about actual onions now. What have you done? But the thing, the thing that I get really a little bit triggered, maybe is the right word. I'm not sure. Maybe I've been full of shit. Maybe it's actually correct talking about ADTs as tagged onions, but. Am I pronouncing it right? Am I giving the listener, like a mental model that we're talking about, like the fruit
Onion? Yeah,
instead
you're
of
saying onions. You mean for the confused listener, we mean unions.
I mean unions.
Okay.
Unions.
But the show notes say onions. That's my whole point.
Oh, yeah.
Anyway, what do you have
Mm.
against what's your gripe with tagged unions?
Tag unions. So tag unions, in my point of view, like it's trying to reduce the idea of ADTs to simply that it's a type constructed by differently in different ways, right? But ADT is not only that. ADT is more than that. And it's more than that exactly in the properties that we are talking about that you need for proper pattern matching and proper type checking, right? You need non-confusion, injectivity, conflict,
Did you
induction,
mention
acyclicity.
non-confusion? Oh, okay, injectivity.
Non-confusion is the name of having injectivity with and conflict.
I see. That's all in
And
Kakan's thesis that I should read.
good question. I'm not sure where I found this. Yeah, my this is actually a note that I took from a presentation that I did forever ago. So I lost the source where I took this from, but it is somewhere. If you look really hard, you'll find this somewhere.
Uh,
I think it might be on Cox's thesis because everything that I took is kind of there. It was really amazing, really summarizing all of this there.
this is how folklore happens. It's just like I wrote it down in a
People
presentation
start
somewhere.
talking, right? Yeah, this.
It's a result attributed to Thierry Kakan that he never wrote, and now
he said in a personal note in an email in
yeah,
2032 that nobody has access anymore, right?
yeah.
So yeah, I think sometimes I see people, like conflating the two ideas of ADTs and tagged unions, and I'm honestly not sure if that's the right comparison. Like that's another thing, philosophically speaking, that I've been thinking of. Um, that what's the name? It's there is a sick plan mentorship thing. Are you on that?
What?
Like there is this sick plan M, which is a mentorship program for programming languages. Are you on that? Do you know what that is?
I've heard of the Sigplan M, but I didn't really
Right.
follow what it was.
I
It's on
think I
Twitter
think it's
somewhere.
pretty cool, and if you have like some 1 hour or 2 hours a week for like you could put your name in there and you could get a someone to tutor, and like
Oh, I
you
would
could
feel so
really
bad
make
about
an
that.
impact.
I would feel so guilty that they got me. Do you want to learn how to not publish any papers? Like,
Dude, I don't know. So here's the thing. So I'm both. I'm both a mentor and a mentee.
oh, cool.
And I'm not gonna mention who my mentor is because I'm not sure how. I think he's fine with being public, but I didn't ask. So I'm just gonna say that one thing that I learned with my mentor that I was really thinking about it is that if you want to learn something, you should go to its source. So, for example, one thing in particular that he was saying, you want to learn category theory, don't learn category theory for programming languages. Learn category theory for category theory, for math, for topological spaces, and all of that crap, right? Because you don't you want to go to the source of the knowledge, right? You want to go to understand something. You really have to dive into it, have to go for the plunge, right? And when you're comparing ADTs with tag onions, we're falling into this trap of trying to understand something in terms of something that we already know because it's more comfortable, it's convenient, and maybe we can make this jump faster. But the caveat here is that maybe it can be actually dangerous to do this because now you're carrying over your assumptions for the thing that you already have that not necessarily translates, right? So I really believe that if you wanna learn something, you have to go to its source. If you wanna learn ADTs, don't think you don't have to think about tagged onions. ADT is not that hard, right? So why say tagged onions? There's no this. Oh, I'm butchering it again. Why say tag unions?
I was like, is that really how you say tagged unions? That's
Yeah,
pretty
it
great.
is. It
I
is.
wait,
That's what.
but you also wrote it. That's so interesting that your accent is
Right.
so strong that it translates into
Right.
your show
Yeah.
notes. Incredible.
Damn, he's showing all my dumbicity. Oh, how I'm dumb here.
Oh no, I mean, I grew up. My parents both have accents, and so I delight in that type of stuff. But so I wanted to ask a question. I haven't really encountered tagged unions in any programming languages. Like I know about ADTs from OCaml and Haskell. So can you give an example of a language that has tagged unions, and also
See,
how what is like a specific example of something where they differ?
well, you have C. They have tagged unions, right?
I thought it had just unions that um are they tagged?
I think they
Um
are.
oh, that's called a tagged union. I just thought they were called unions. I've been
Yeah,
using tagged union like as synonymous with ADTs this whole time. So the point is, but you do have just like for example injectivity and conflict with tagged unions, don't you?
but you don't necessarily have induction and acyclicity.
Uh-huh. So those are the key differences.
But um, maybe you have injectivity, but conflict is a little harder to get by sometimes. I don't know. But the thing about tagged union is that it doesn't necessarily comes with pattern matching, and that's the key for me.
Right.
You want pattern matching,
Hmm.
and in order to have proper pattern matching, you need these properties, all of them, right? And pattern matching is beautiful. It's one of the most beautiful things in functional programming languages, in my point of view.
I think it might be what sold me on functional programming language
Yeah,
was somebody
yeah.
showed me
It's
pattern matching, and it's like if C had pattern matching, then I would never have
right,
switched.
right. Yeah, yeah. See, like makes your life pattern match makes your life so much easier and bug free, and like it's so natural to think of your programs in terms of pattern matching, of really looking at your data specifically this way and that way, right? There was this one guy that he was asking on Twitter the other day. I don't remember his name, and even if I remember, I probably wouldn't mention. But he would say, he was asking what imperative programming language could, like I blanked a little bit, but like his point initially was that you cannot have imperative programming language with ADTs, with algebraic data types, and I was like, no, you can. They're not mutually exclusive, and you have it in Rest, for example, right?
Yeah, exactly. I was gonna say.
Yeah, yeah. But that's a key. Like you usually think of ADTs in the realm of functional programming language, but that's not necessarily the case. It's just where they were born and where things, like really where they really shine, but it's not necessary. It's just knowing how to implement them properly. ADTs, and then you have pattern matching, and pattern matching is just an elimination form of for ADTs, and you're done. That's it. There is nothing saying that you need to be tied to a particular programming, like what's the word? There's programming paradigm, something like that.
Mhm.
I think we should start moving towards the wrapping up of the episode, because I think we're running out of time.
Okay, how do we end this podcast?
Well, I don't know. You're the host. You'll tell me.
Everybody, thanks everybody for listening to Type Theory for All. One thing that I was thinking of on my way to the show was that since you're going to be coming back to the States for a bit, and I'm going to be moving to Chicago, that we could have a Type Theory for All meetup in Chicago.
Ooh, I like that. I like that. Let's make it happen.
Yeah,
But this is only for the premium
that's
subscribers of
right.
the
That's right.
podcast. There's just a patrons that doesn't exist.
I was going to never mind. Set up an OnlyFans account for the type Theory for All.
All right, guys, you can check Dan's OnlyFans account on typetheoryforall.com. Well, I think we talked about everything that we wanted to talk, and to be completely honest, I think I even talked much more than I expected to talk, and I really appreciate that Dan made those questions and that I could talk about this a little more public. There's a lot more about my time in Brazil that I still will share with like my closer friends, because I think it was such a I think I lived like 5 years in one. Honestly, I did so much. I met many people. I went to so many places. I had so many experiences. So I hope I can share my gratitude and like my um all my everything that I learned with you guys and my friends and people around me, and that it can like maybe help not only me but people around me. So thank you so much, Dan, for being here. Thank you for talking a little bit about your research, about your experiences. Thank you for like hosting more than half of this episode. And maybe like I was thinking about it, and I think I'm actually looking for a co-host, a kind of partner. If you'd be interested, we could like I'm interested in inviting you some other time to co-host with me. I think it would be really cool.
I would
So if you'd be
absolutely love
interested, we
that.
could
Um,
talk about it.
but yeah, that's a very flattering idea. We'll see how this episode does, and if they're like, "Who's this asshole?" Then we'll be like, "Okay, probably shouldn't have this guy on the podcast again." But it's been so
So
much fun. Yeah, I'm really pleased to be on the podcast, the definitive Type Theory podcast of our time, of our age. And I want to thank you, Pedro, for setting it up, for one, for setting up something for our niche little community. And number two, for talking, really those really personal experiences that you had dealing with burnout and with all the pressure of that. I think everybody listening probably can relate to it. And I personally, I don't know, I felt a lot of connection to what you were talking about while you were saying it. So I'm grateful to you for having opened up about those experiences.
Well, thank you so much, man. So one thing that I usually ask towards the end is that if there is anything that our guest thought that he wanted to talk about, but he didn't have the chance, or there's any questions that he thought that should have been answered. So I make you that question.
What do people usually say to that? I've never gotten to the end of one of your podcasts, so I don't. Oh, no,
They're
no
that
offense.
boring, huh?
I think like halfway through the podcast, I'm always like, I should be doing work. I should be.
People usually say no.
They usually say no.
Or they give. Oh yeah, one thing that I also ask is like, is there any social media, any platform that you would like to advertise? Maybe your Twitter, maybe your OnlyFans account.
Yes, everybody, please follow me on Twitter. My handle is D Plyukhin. I think maybe Pedro will put it into the show notes. And also, I'm going to be.
Yep.
Oh, you have show notes, right? You guys
Yeah.
have the technology? Okay. Show notes technology.
Yeah, it got to Brazil.
It's made it all the way down there. That's really great. The other thing is that I'm moving to Chicago. So if there are any Chicago listeners of the Type Theory for All podcast, I don't need to know any more about you. Please reach out to me. I want to be your friend. So any listeners who are out there in Chicago. And set up that meetup. That could be pretty interesting if we get around to it.
All right, dude. Yep, that's it. I think we nailed it. And thanks everyone who stayed until here. Goodbye.
Peace.
Well, that was it for today's episode. Thank you so much for everyone who could stand me just talking for all this long. I know that I usually don't talk this much. I try to be as quiet as possible because I usually don't think I have that much cool stuff to share, but I don't know. Maybe sometimes we have more cool stuff to share than we expect, huh? I hope you guys enjoyed this episode. If you guys have any questions and comments, please leave it on our website, typetheoryforall.com. Or if you don't like your name being there, you can just send an email at typetheoryforall@gmail.com. And don't forget to follow us at Twitter at TT4All. I think that's it. I will see you guys next time.